Okay, section 4.6, we're going to graph secant, cosecant, tangent, and cotangent. And hopefully you have a good handle on graphing sine and cosine because they're important for graphing these functions. So in chapter 3, we looked at functions like f of x equals 1 over x. Those are rational functions. And when you think rational, think fraction. And when you think fraction, think the denominator cannot be 0. That's the most important thing. We saw that the graphs of rational functions have asymptotes at x values, which make their denominators equal to 0. So since secant, cosecant, tangent, cotangent are all reciprocals or rational expressions involving sine and cosine, you're going to have that problem of having a denominator that equals 0 at certain places, and at those places you're going to have asymptotes, which are lines that the graph will approach but never touch. So let's take a look at cosecant. The graph of cosecant, y equals cosecant x, is just the graph of 1 over sine x. So the best place to start is to remember that whenever sine x is 0, the graph of cosecant is going to have an asymptote. So if you look at the sine graph right here, you can see where it hits the x-axis. That is when its value is 0. And so at any of those places, the cosecant graph is going to have an asymptote. Also, an easy thing to remember is that there will be no x-intercepts because 1 over sine x can't be 0. There's nothing you could put in there for x that would make that equal 0. And then also what's a simple thing to go ahead and put on there is that when sine x equals 1, cosecant is also 1 because it's just 1 over 1. So looking at the sine graph, you can see that it has a value of 1 at the top of those little hills. And so cosecant will also have a value of 1 in those places. So those dots right there, those points, will be on your graph of cosecant. And then similarly, when sine is -1, cosecant will also be -1 because it'll be 1 over -1. And so those little valleys there at the bottom, those will also be points that are on the cosecant graph. And so once you look at all this, there's only one way to graph cosecant. It's got to approach those asymptotes. It's got to go through those points. So there is part of your cosecant graph. And then another part is right there. And that's all this graph ever does. It just repeats it over and over again. So you can see right here that it takes 2 pi radians to do its thing, to do all of its stuff, those two curves. And so the period is 2 pi. And if you graph the whole thing, you can also see that it is symmetric about the origin, just like sine is. And so it is an odd function. So that's what the cosecant graph looks like. And here are all the details about the cosecant graph. The domain is x not equal to n pi. N pi, those are multiples of pi, and those are the places where sine is always 0. You can never have an x value that makes sine 0. For the range, you can see that this is going to be 1 and greater or -1 and less. It can't be in that area between -1 and 1. Also, the amplitude, there's no amplitude here because it just increases without bound. The period is 2 pi, like we just said. The vertical asymptotes happen when you're at multiples of pi because that's where sine is 0. And then, like I said, it is an odd function. So that's cosecant. Secant is very similar. So secant is 1 over cosine. So whenever cosine is 0, the graph of secant is going to have an asymptote. So if you look at the cosine graph, which looks just like the sine graph, except that the maximum happens at 0, anywhere that graph touches the x-axis, that is going to be when cosine is 0, and that is where you will have asymptotes for secant, because secant is 1 over cosine, and you can't have 1 over 0. So those are the asymptotes. Same thing as with cosecant. When cosine x is 1, secant is also 1 because it's just 1 over 1. So those points, those maxima, are on the secant graph as well as the cosine graph. And same thing for -1. When cosine is -1, secant will also be -1 because it's just 1 over -1. So those points will also be on the secant graph. So once you get here, everything is spelled out for you. You can't draw this any other possible way except with these U curves. And you can see that it still takes 2 pi radian to do that. all that stuff that it does. And then it just repeats it all over the place. And so it looks like this. It is, as you can see, it is even. It's symmetric about the y-axis. And so all the details for that are right here. The domain is going to be x such that x is not equal to any odd multiple of pi over 2, because the odd multiples of pi over 2, that is where cosine is 0. So you can't have those in the domain. And again, the range is just 1 and up and -1 and down. There's no amplitude. The period's 2 pi. The asymptotes happen at odd multiples of pi over 2. And then it is an even function. So that's all the stuff you would need to know about secant. So let's graph one of these. You've got y equals 3 secant 2x. All you need to do here is go ahead and graph y equals 3 cosine 2x and then do what we just did. So we're going to graph y equals 3 cosine 2x. And you can see here that the amplitude is going to be 3 and the period is going to be 2 pi over 2. So that's pi. So we can graph the cosine graph that looks like that. It has an amplitude of 3 and a period of pi. So once you've graphed that, you can now graph y equals 3 secant 2x. You just put your asymptotes whenever this graph is 0, whenever the cosine graph you just graphed is 0, wherever it hits the x-axis. The maxima will have points on the secant graph, and the minima will also have points on the secant graph, and then you just graph it. And that's what it looks like. So this is the graph of 3 secant 2x. Okay, so example 2, we're going to graph y equals cosecant of x minus pi over 4 plus 3. So to do that, we're first going to graph sine, the same sine function. So sine x minus pi over 4 plus 3. So we have to look at that to see what we know about that function. So we know the amplitude is going to be 1 because it's just 1 sine x minus pi over 4. So that is going to be the amplitude. And then there's no period change because there's nothing multiplied by x that we had to factor out or anything like that. So period will be 2 pi. So it's just a regular looking sine function to start with. And then we notice there is a phase shift. Minus pi over 4 means that it's going to be skewed to the right, pi over 4. So that's what we have. And then plus 3 after that means that we need to shift it vertically up 3. So that's going to look like that. So kind of our new XY axes are right there. And so all we have to do is notice that we're going to have asymptotes wherever that graph crosses the horizontal axis, which is now 3. So those are going to be the asymptotes. And then also the maxes and mins will have a point that's going to be on the cosecant graph. So we put those points and then we just make our little U shapes. And that is the graph of cosecant x minus pi over 4 plus 3. Okay, so the graph of tangent is not a reciprocal, but it is still a rational function. It is sine x over cosine x. And so you can talk about what tangent's going to do based on what sine x and cosine x do. So if you look at the sine graph, since sine x is the numerator of tangent x, whenever sine x is 0, tangent will also be 0. So the tangent function is going to have zeros or x-intercepts wherever the sine has x-intercepts, same place. All right, tangent is sine over cosine, so cosine is the denominator. So look at the cosine function. Whenever that is 0, you're going to have an asymptote because you can't have 0 in the denominator. So if you look at that cosine function, wherever that hits the x-axis, you're going to have asymptotes for your tangent function. So it's going to look like that. So to figure out where to graph these curves, we know they're going to be between the asymptotes. We know they're going to go through those x's. We know that since tangent is sine over cosine, whenever sine and cosine have the same sign, so if they're both positive, tangent will be positive. If they're both negative, tangent will be positive. But if they have opposite signs, you'll have a negative over a positive or a positive over a negative, so you'll have a negative value. So looking at the sine and cosine, if you can look from 0 to pi over 2, you can see that sine and cosine are both positive. That means that tangent will also be positive, so it'll be looking like that. If you look between 0 and negative pi over 2, you can see that cosine is positive and sine is negative. So they have opposite signs. So tangent is going to have a negative value down there, and it's going to be approaching that asymptote like that. And same thing over here from pi over 2 to pi. You can see that the sine and cosine have opposite signs, so that's going to be negative for the tangent going down like that. And then from pi to 3 pi over 2, sine and cosine are both below the x-axis. They're both negative, so that makes tangent positive, and it heads up like that. So all the tangent curves look like that. That's what your tangent function is going to look like. You can see that it has a period of just pi because each curve goes pi radians. So if you look from negative pi over 2 to pi over 2, that function does everything it does. And so that's the period. Period is just pi. You can see that it's an odd function. It's symmetric about the origin. I think that's pretty much everything you need to know about the tangent graph.